Hello again. Thank you for joining us on another episode of Space Nuts. My name is Andrew Dunkley, your host. It's great to have your company. As I mentioned last episode, Fred is away for a few weeks or a couple of years. No, it's a few weeks. And in his stead, we'll be joined by Professor Jonti Horner, who you know and love because he's been with us before and he's a part of the team. So we will be doing over the next several episodes, taking a different approach. We're going to focus on specific topics within each of the episodes. We could call them specials, if you like. And today, our focus will be on comets and meteors. Stick around. We're doing all of that on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And it's great to have him back. Professor Jonti Horner, Professor of Astrophysics at the University of Southern Queensland. Jonti, hello.
Hey, how are you going?
Good. Great to see you again.
Well, it's good to be back. It's something nice to keep me entertained while I'm having a little bit of a restful couple of weeks. I've got a bit of leave, so I'm recovering from a minor surgery, and therefore I can give my entire focus to talking about fun things rather than doing admin effectively. But means I get to see a little bit of the life Fred gets to live. Yeah,
maybe, yes. Although he doesn't seem to slow down much. In fact, I think the worst thing you can do when you retire is slow down because the brain matter decides to give up the ghost, and that's when it's all over Red Rover. But no, he's going great guns. And you didn't mention that you're having a little bit of a recuperation. Are you in a position to talk about that, or is it too embarrassing?
It's one of those things that when I first had this pointed out, I was a bit embarrassed about it, but I don't think as blokes we ever talk about health that much until it's worth muscling past a little bit of embarrassment. So I'm in my late 40s and I went to the doctor about a year ago because I had a little bit of bleeding when I was sitting down and stuff like this, and nothing dramatic. But I found out two things. Firstly, in Australia, and I don't know about the rest of the world, you should look this up, but when you're in your 40s, the Medicare system here affords the opportunity for you to get health checks.
Yep.
Which is brilliant. So you basically get what in the UK they'd call an MOT for a car. You get everything run over and you get your blood pressure done and your heart rate done and everything else. And then you go back every 3 months and do it again and again and again. And it's basically, you're at an age where things start to break. Let's get on top of it early so that you can enjoy the rest of your life in peace, effectively. Yeah. I think it's a really good idea. And I suspect from a government point of view, makes a lot of sense because if you find things easy earlier, they're easier and quicker and cheaper to solve. What it turned out from that was I spent about 2 months going back and forth with a doctor who thought I had one thing wrong, which is not what it was. And then I got sent to this specialist who said, you've got something called a fistula down near your backside. Which, not life-threatening, not the end of the world, not doom, but it's uncomfortable. And, it's been slightly embarrassing in that I've had to learn more about sanitary pads than, you would have expected, which the women in the audience are going about bloody time a man learned about this. But it's a weird one because it's not life-threatening. It's nothing of a problem. 10 or 20% of guys apparently get them, but they can take multiple surgeries to fix. And when I went in for the first surgery in January, there was another guy there who was on surgery number 7.
Wow.
Which, deep and joyous. Kind of day surgery, but you get a full general and you go under and doctor does snippy things and you get a couple of weeks off work, which is where I am now. So I've just had surgery number 2 and the doctor is hopeful, confident, whatever, that surgery number 3 will be the final fix. And it's one of these weird things because people say, what's wrong with you? And if it's a sore arm, you just say, I've hurt my arm, or you've broken your arm or something like that. Or in Australia, a really common one, a melanoma. People have been in the sun too much, going into hospital, what do you get? Oh, I've got a melanoma taken off. But as soon as it's anywhere between about your belly button and your knee, people are bashful about talking about it. And first few months I was mortified and wouldn't talk about it. And the realization is that if you don't talk about it, people don't get checked. And we as men are terrible for that. And so, worth talking about. I'm a bit embarrassed about it, but I shouldn't be. And it's good because I get to tune up, and it means that in 40 years' time, I'll still be up and kicking and having a lot of fun rather than in discomfort and grumbling about a problem I could have got fixed.
Yeah. And I think you're right. I think men do tend to keep things to themselves. A lot of them go into denial, or they just think, well, no, that won't happen to me, so no problem. But when I was diagnosed with prostate cancer, it was like a bolt from the blue, and I never expected to get it because there was next to no history of it in my family. So that was a bit of a shock. And this is, how long is it now? 3 years? 3 years, and I'm still working my way through it. So, but the latest scans are all good. So fingers crossed that we've, reached a good position. But it's just an ongoing thing in your life. You just got to get used to it. But my advice to men is go and get checked. If you're over 50, go and get a prostate exam. Go and get your PSA tests done, because if you don't, and then they find it, it might be too far along, and then the treatment becomes more dramatic. So anyway, it's a good thing to bring up.
It is, and it goes for the mental health stuff as well. I have a former partner of mine kind of 20 years ago who was very severely bipolar, had a lot of challenges. And she was continually frustrated by people's responses to that in public, in that it's a hidden illness. It's there, she's getting treatment. But what she always said is it's really frustrating if I had a broken leg or I had an injury to my arm and people could see it, they'd be supportive. But with mental health, she got a hell of a lot of, just get over it, or toughen up, or...
Yep. Yeah.
And she was female, so she's more likely to go to the doctor and talk about it statistically. Men with mental health challenges tend to avoid that even more than they'll go to the doctor with physical health challenges. And it's something I'd like to see change. I come from a working class background in Yorkshire where men don't talk about anything. You're meant to be stoic, and the only expression of emotion you're allowed is rage or a single manly tear. It's really crazy the way we're conditioned. And even though I went to uni, I've had a life, I've grown up, all this stuff's still there at the back of your head, and you've got to fight against it because the instinct is, there's nothing wrong, I won't bother.
Yeah, yeah. And, you see it way too often. I know it's a departure from what this podcast is all about, but I when given the opportunity, will openly say to men, don't hesitate to go to the doctor. Not when you think something's wrong, just preemptively go and get once a year, go and get checked and make sure everything's where it's supposed to be, or whatever.
We do it for our cars, we do it for our pets.
Yeah, do it for yourself
as well.
Yeah, exactly.
And I think it's probably a record for the quickest we've ever got off topic, and possibly we should have a trigger warning at the front of it and all the rest of it. But no, good way to start, even though it is off topic.
It's okay. We'll get on to topic right now because, as I mentioned, these next several episodes are going to be dedicated to singular topics each. And today, it's related topics: comets and meteors. This is a pet topic of yours, I imagine.
It is. I've always been a bit more into the nearby stuff than the more distant stuff. So it always tickles me a little bit that when questions come in when I'm on the show, we get all the Big Bang and cosmology ones. And I'm sure if you got someone like the wonderful Tamara Davis on to talk cosmology, she'd get all the planets questions. It's always the way it goes. Yeah. But comets and meteors are a big part of what hooked me into astronomy as a kid. And my thinking behind this is that we're recording in advance, obviously, Fred is away, but you've got recordings with Fred already. And so the news that we would normally talk about hasn't happened yet. So I have many talents, but seeing into the future isn't one of them to that degree. And so I thought it better to have a discussion about the general stuff in a bit more depth than go into particular news topics. And it could almost be a bit of an explainer, a bit of the background, and hopefully at least gives my insight into why a given topic's interesting, but also what people can look out for in the future and how they can get more into and more out of that particular topic, if that makes sense.
Yeah.
A little bit different. I understand for some listeners it might be a bit of an abrupt departure and a change, so it'll be interesting to see what feedback you get. But hopefully people like it as a little bit of a change and a breath of fresh air. And if they don't, well, there's only a couple of episodes and Fred's back anyway, so you'll have to deal with it and we'll see.
I'm sure it'll be fine. Comets and meteors are a very popular topic. So where do we start? Maybe look at a bit of the history of this.
Yeah, I think that is always a good place to start because it sets the context of where we are now. And for both comets and meteors, there's a kind of global connection societally that really predates by a long, long way our scientific knowledge, essentially the modern scientific viewpoint and the scientific method. All cultures across the world, from our wonderful traditional owners here in Australia to the peoples of every continent and every land, both current and past, historically had a really firm connection to the night sky. They knew the night sky better than most people these days do, because there wasn't light pollution, there weren't TVs and Xboxes. So the sky was something people were much more exposed to. A lot of cultures had this kind of idea of as above, so below, as below, so above. So they were very firmly of the idea that major events on the Earth were reflected in the sky, and major events in the sky would have their counterparts on the Earth. And that's where astrology was born. And for a long time, astrology and astronomy were one and the same. You know, people doing astronomy studies were doing it because they wanted to understand the events that would influence what's on the Earth. And there are good examples of this in terms of the nominally fixed stars, things like the ancient Egyptians using the rising of Sirius in the dawn sky after it disappeared in the evenings as a predictor of the flooding of the Nile, for example, the use of the night sky as a calendar. Lots of stuff like that. But because people were so aware of the night sky, anything that was ephemeral, anything that was transitory, that appeared and then disappeared, that was unexpected, was often seen as kind of a portent or an omen, something that was an indication either of major change and upheaval currently happening or one soon to come. And really bright comets and spectacular meteor showers kind of often filled this role. And you can go back through ancient history where we have the records and see good examples of this. I've got in one of my talks about a guy called Mithridates, Jupiter 6, I think his name was. He was one of the great enemies of the Roman Empire. And there are quotes ascribed to him saying things like, even the heavens predicted the greatness of this man, for in the year in which he was born and the year in which he came to reign, a comet shone through both periods for 70 days, as bright as the sun. Each rising and setting took 4 hours each. And that's kind of hyperbolic, but it gives this idea that people saw something in the sky that was unusual and tied it to events on Earth. Another good example would be the alleged comet called Caesar's Comet in 44 BC, 43, which is recorded in Roman writings from a century or two later, talking about after the death of Caesar, a comet blazed in the sky for 7 days that was spectacularly bright, then disappeared and was never seen again. Now, that comet is a really good example of the challenge people have with historical records. Because on the one hand, you've got these clear reports from the Roman Empire, none of them at the time, though, all of them a bit later on. But that comet is not recorded from anywhere else on the planet. And there were cultures around the globe leaving records like ancient China and ancient Korea who would have seen it. So was that comet real? Or was it a case of, after the event, people inventing a night sky phenomena to tie with the soul of the emperor rising to heaven? It's one of the challenges people in the kind of cultural astronomy space face, I think, in terms of disentangling the narrative from the events that prompted it, if that kind of makes sense.
Yeah.
But what's certainly true is that for as long as we've looked at the sky, really bright comets and unusually powerful meteor showers were things that people took note of. And recently there was a lot of media coverage of the April Lyrid meteor shower, which is not one of the strongest of the year, but one of the reasonable, moderate ones. It's the kind of one that if you're a meteor enthusiast, you'll go out and watch, but isn't worth going out if you're not that interested because there's too few. I had to grumble about some of the coverage here in Australia because it's not a great shower for us. But that meteor shower was recognised by the traditional owners in Australia, and there are stories from Victoria, from I think the Burong people, although I stand to be corrected on that, that associate this meteor shower with the malleefowl, one of the big ground nesting birds in Australia, which nests around that time of year. The meteors seen shrieking from low in the northern sky were viewed as being the dust being kicked up by the nesting bird celestially. So they recorded this meteor shower even though it isn't a particularly strong one. But our oldest written record of any meteor shower is the April Lyrids, and it's dated back to something like 687 BCE, when stars fell like rain, when there was a major storm from the Lyrids, and it was significant enough for people to record. So comets and meteors, way before the modern scientific understanding of them, really had this important cultural role Even in the Battle of Hastings, if you ever go to see the Bayeux Tapestry, this wonderful woven record of the Battle of Hastings and the invasion of William the Conqueror, Comet Halley features prominently on that, because in 1066, you had the second best apparition of Comet Halley in the last 2,000 years, arguably. It was very spectacular in the sky at the time the conquest was going on. And that was considered important enough to be recorded in the tapestry that was woven at the time. You know, it's amazing that you've got this panel where there's all the peasants pointing up at this thing in the sky and somebody whispering in King Harold's ear about the comet that's visible. So I don't know whether the invading forces took it as a good sign or a bad sign, but they thought it was important enough to include. So that in itself is fairly breathtaking. And so when we see these objects, it's a lovely connection to thousands of years of our heritage of people looking at the night sky in wonder. I think the first step we had really in moving from cultural cometary astronomy to modern scientific astronomy in a way came with the Great Comet of 1577, which was another of the really amazing, spectacular bright comets. That was widely observed, hence why it's a great comet, but it was observed by the great astronomer Tycho Brahe, and I'm sure Brahe has featured on the podcast many times before, but the quirky individual he was, it's well worth looking up his Wikipedia record. He's this wealthy nobleman with a silver replacement nose after he lost half his nose in a duel. He's that guy. Yes. He had a pet moose that died when it fell down the steps because it got drunk at a banquet. He really odd man, but probably viewed as being the last great pre-telescope astronomical observer, if that makes sense, naked eye observer. Now, at this time, comets were kind of thought to be probably atmospheric phenomenon. They were nearby, high in the atmosphere, and so that was what was going on. People had that kind of idea. He realised that if that were true, these things would display a noticeable parallax if people observed them from different locations. So in other words, people looking from different locations would see the comet in a different place in the sky because it was in the foreground. It's the same technique we use to measure the distance to the nearest stars. If you put your finger in front of your face and look at it through one eye and then look through the other, you'll see your finger blinking side to side, and the further away your finger is, the less it moves. We use that to measure the distance to stars by observing from one side of the Earth's orbit then the other. But what Brahe did was collect observations from around Europe of where the comet was in the sky. With those observations, he would have been able to detect a parallax for the comet if it were closer than the orbit of the moon. So if it was atmospheric, absolutely, definitely would do. But no measurable parallax was found, which showed the comet had to be at least a couple of million kilometres away, and in fact it was probably several tens of millions of kilometres distant. He got this beautiful figure, and I use this in my talks occasionally, that is his drawing of the motion of the comet, and it's fascinating from a cultural point of view because it's clearly at the time when you still have the geocentric model, the Earth was the centre of the universe. So you've got the Earth in the middle, the sun going around the Earth, but then Mercury, Venus and the moon going around the sun. It's kind of weird hybrid thing. But you've got the path of the comet moving through there that he's determined. And what's really interesting to me, what's really fascinating, is he's got the tails pointing away from the sun all the time. So he's got the phenomenology of where the comet is in the solar system, modulo the sun's going around the Earth, and the tail's pointing the right way as it moves, tails of comets always pointing away from the sun. And to me, that kind of marks the dawn of the modern scientific view of comets from the cultural, we don't know what they are, but they are important. I think that's a real kind of boundary point for me.
Yeah, fascinating. I was actually going to ask you about the the point in time where we went from the mythology to the understanding that this was something else, and you covered that beautifully. I'm going to just take a breath on Space Nuts. You're with Andrew Dunkley and Professor Jonti Horner. Let's take a short break from the show to tell you about our sponsor NordVPN and to discuss your online privacy. Because let's face it, these days, whether you're browsing at home or jumping onto public Wi-Fi at a cafe or an airport or wherever, your data is constantly at risk. Hackers, trackers, even companies you've never heard of, they're all trying to get a piece of your digital life. And that's where NordVPN comes in. Our sponsor is fantastic. It's one I've been using for many years now myself, and I have absolute faith in their product. NordVPN encrypts your internet connection, hides your IP address, and keeps your personal information safe from prying eyes. It's like putting an entire online world inside a secure tunnel. They've got over 7,700 servers worldwide. You can browse fast, safely, and without restrictions. Plus, features like threat protection and ultra-fast speeds with Nord links mean you're not sacrificing performance for security. You get both. Right now, you can grab our special Space Nuts deal and get 4 months extra for free. Plus, there's a 30-day money-back guarantee, so it's completely risk-free to try. Just head along to our special URL, nordvpn.com/spacenuts. That's nordvpn.com/spacenuts, and don't forget to use the code SpaceNuts. That's nordvpn.com/spacenuts. Stay safe, stay private with NordVPN, our sponsor.
0G, and I feel fine.
Space Nuts.
I did say a breath. That was quick. Let's continue talking about comets and meteors. There have been a lot of them in the news of late. Comet Pan-STARRS is, it was very, very popular late April, and we've seen in recent times a new kind of comet, and those are the ones that are coming from other systems, not the ones that are continually rotating through our own solar system. We've had these exocomets that have been quite intriguing and opening up all sorts of new ideas and questions about comets and other parts of the universe and what we could learn from them. And new comets are being discovered all the time. That doesn't mean they haven't been here before, but it does mean that they've got very longitudinal travel times. So, some we won't ever see because we'll have been and gone before they get here, and others we'll maybe see several times during our lifetimes.
Absolutely. Now, historically, people broke the comets we found down into two categories. We had short period comets, which are comets. The definition when I was a kid was comets whose orbital periods were less than 200 years. Shorter than that, and you were a short period comet. Longer than that, and you were a long period comet. Now, there are subtleties within that. Within the short period comets, we have comets like Comet Halley, which are called the Halley-type comets, which come round with a period comparable to a human lifetime or a bit longer. And the two brightest and most famous of those are Comet Halley and Comet Swift-Tuttle. You then have the Jupiter family comets, which are comets whose orbits are just a few years and are typically under Jupiter's control. And when I was a kid, anything longer than 200 years was considered a long period. Now, that kind of got smashed into the ground a bit in the early 2000s when Comet Ikeya-Jang was sighted, because Comet Ikeya-Jang was very well observed. Its orbit was well calculated, and it was found to have a period of 366 years, I think it is. And that allowed people to identify the previous observations of that comet from the last time it was around. So that's currently the record holder where we're absolutely certain that it's been seen on multiple occasions, and it has a periodic comet designation now. Now, a subtlety to that is we do have the Kreutz sun-grazing comets, and I can talk more about them a little later, where we have a strong identification between an observation of the comet, say, with Comet Ikeya-Seki in 1965, and a previous apparition in the 1100s, which is about an 800-year return.
Yeah.
But that's a bit woollier because the comets we observe now are fragments of one comet back then, and so therefore several comets tied to that initial apparition. So there's all that complexity there. We then have the long-period comets, which, like I say, were 200 years or more. It still kind of is, but with those objects that are both long period and short period, thanks to Ikeya-Jang. You've got these objects whose orbital periods are so long that they are markedly longer than a human lifetime, even if they're comets that have been through before. So a good example of a really bright comet that is considered long period but has been through many times before is Comet Hale-Bopp.
Yes.
Comet Hale-Bopp was spectacular in 96-97. It was visible with the naked eye for 18 months, shattering all the records. It will be back in about the year 4400. It was the last around when the Egyptians were building pyramids. And that is perversely a long period comet with a relatively short period orbit for a long period comet. And so scientifically, we'd call that dynamically old or not a new comet because it's been around a number of times. At the very long period end of the long period comets, you get things that are coming in from halfway to the nearest star from a region we describe as the Oort cloud or the Opic Oort cloud. And those things on their way in have calculated orbital periods of hundreds of thousands or even millions of years. And many of those actually only come through once, and then they get nudged and ejected from the solar system, never to return, going out to wander among the stars. And it's objects like that that will become the interstellar comets for other stars, in the same way that this third group of comets that you alluded to that we found recently are interstellar comets in our system. So these are the objects coming through so quickly that they are not gravitationally bound to the sun, but also so quickly that there is no possibility that they ever were. They've been flung in so quickly that they must come from another place. The most recent one was 3I Atlas, which got talked about a huge amount.
Yes.
Was definitely not an alien spaceship. And to avoid getting too political, just a very brief comment on that because it needs to be stated and restated, which is the arguments of that being an alien spaceship were the work of one person. One person who is not a solar system astronomer historically, but has reached that age and level of senility that they believe they can be an expert in things that they are not, and has a certain financial interest in keeping people interested in aliens because they buy his book.
Click that.
And the community of astronomers has been very upset and very stressed about that because it diverts attention from what is a really fascinating object on the fact that it's really fascinating, but also breeds a certain amount of fear. And I genuinely had people reaching out to me when he was pushing this narrative of it being aliens that were going to invade because they were frightened. They were genuinely worried because a Harvard astronomer was saying aliens were going to come and beat us all up.
Yeah.
And it's problematic because it hides the science, but it's also more widely problematic at a time when we have lowering levels of engagement with science and very much lowering levels of trust in science and scientists. It's very bad to have someone acting disingenuously, telling lies or muddying the water, and then arguing that everybody else is wrong and mean to me and I'm the only one telling the truth. And it's part of that whole fake news thing that I think is dangerous and damaging. You know, we need people to have trust and faith in science because it's so integral to our lives, and it's good to question, but it's bad when people say things that they fundamentally know are not true just to get hits or clicks or money.
Yeah, and it's important to debunk that kind of approach because I've had people come up to me very recently who know I do this podcast who've said to me, "Oh, what do you think of that alien spaceship?" And I go, "It's bullshit." That's what I think, because it's somebody trying to get media attention. It's got nothing. It's a rock. It's actually it's an ice conglomerate. It's not a spaceship at all. It's not behaving like a spaceship would. It's behaving like something passing through our solar system.
And
people. The thing is, Jonti, people are buying this rubbish.
But there's an old saying that, you know, a lie can run around the world before the truth has got its boots on, especially when it's an attractive lie. It's, I mean, again, digging into my memories of Terry Pratchett stuff, which happens a lot. It's the old quote when they're talking about newspapers, and nobody really ever wants to hear a story about dog bites man because it happens all the time. But if you've got a story that says man bites dog, everybody's fascinated.
Yeah.
And this story has all the elements. It's so salacious that it gets coverage, and people who don't normally read or digest science are not interested will see this and hook into it. And when the byline is Harvard astronomer, that gives it a huge amount of credence.
It does.
And nobody hears the rebuttals. It's a bit like, you know, when there are claims of life on a planet around another star, nobody remembers the follow-ups that say actually it wasn't. They just remember, oh, we found aliens, and we haven't.
And I think the story that the most recent story that I recall where that claim was made was the one about something what was it they found in the atmosphere of Venus? It was phosphine. Yes.
Now, I can go on a little bit of a side rant about that. My heart broke. The lead author on that study was Jane Greaves in the UK, who's someone I knew very well when I was in the UK, and she's a fabulous science and just all-round wonderful individual. And the story was led by a UK team who, if you actually read the paper, don't say anything that is, this is life. What they say is we found a very weak signal of this gas in Venus's atmosphere. It's right down in the noise, so there is a chance it's a false positive anyway. So there needs to be a bit of extra work done. It's a little bit interesting because on the Earth, the only processes that produce this peculiar gas are technology and industry or life.
Yeah.
We don't know of any other way that it's made, but that doesn't mean that there aren't other ways that it's made.
Isn't that a tasty morsel for the popular press?
Absolutely. But what happened then was that there is an American outreach journal, science communication journal, that broke embargo on this story. Didn't talk to Jane and her colleagues, but instead ran a story saying British scientists found life on Venus, which is not what they'd said at all.
No.
And that's what started the absolute bum fight. And the vitriol and the hate and the death threats, believe it or not, that Jane Greaves got because of this were astonishing. It was absolutely terrible. And instead of being able to manage the deployment of this wonderful story about this fascinating new result they got, they spent all their time in damage control because this publication chose to break the embargo early and run a story that was not factually true, but that, again, would get them clicks.
Yep. Yeah, and that's unfortunately the modern media, and the internet's to blame. Well, it's not the internet that's to blame; it's the people who use it that are to blame. And it's one of the things you've really got to be careful of when you are following a story, whether it's an exocomet that's not a spaceship or life that's not in Venus's atmosphere, and even to a lesser degree, and you and I mentioned this before we started, the way the media gets its information confused, such as reporting on upcoming spectacular meteor showers that everyone gets excited about, and then they realise they're on the wrong side of the planet.
Absolutely. And this is a caution I give to everybody, both for comets and for meteors, actually, but particularly for those of us in the Southern Hemisphere. Meteor showers and comets are things that are best seen from some latitudes and not from others. And for each comet or for each meteor shower, that's different. Now, I'll talk later on about a newly discovered comet that might be very spectacular in late 2028. That comet is primarily going to be a Southern Hemisphere object. So it will probably be better for us in Australia and New Zealand than it will be for people in the UK or the US, just as an example. When events are happening that are primarily good for the Northern Hemisphere has more people and more media. And what I've seen happen more and more is that the media in Australia, and I know the Australian stuff because that's local to us, it's probably just the same in New Zealand, South Africa, South America, all these other places. But the media there will pick up these stories and just run them without running the sanity filter. So the April Lyrids are a really good example of this, but a better one is probably the Perseid meteor shower in August. Now, as a little bit of background here, when we've got a meteor shower, we're getting bits of dust and debris hitting the Earth's atmosphere and ablating at an altitude of about 80 kilometers. Now, ablation is a slightly weird thing. People often describe this as burning up, but it's not burning up in the sense of a flame being lit and a fire burning. It's rather that these things push into the atmosphere at really high speed, pile the air up in front of them, getting the air superheated, creating a load of plasma, and the heat from that bakes and vaporizes the bit of debris. So it's not burning up in the traditional sense. And anytime you see a meteor, you see a shooting star, that's what you're seeing. And the bigger the bit of dust, the brighter it will be. The faster it's moving at a given size, the more energy it's got. So again, the brighter it'll be.
Yeah.
And you see shooting stars on any night of the year, typically 3 or 4 an hour in the evenings, 5 or 6 an hour in the mornings potentially. And that difference is just because in the mornings you're facing the direction the Earth's moving, so you're getting collisions that are head-on. So the average collision speed is higher. So a grain of dust that's the same size will be a bit brighter. Therefore, the things that in the evening that will be too faint to see become visible. So you get a slight increase in the rate towards morning than in the evening. It's also, you're probably getting a slightly increased amount of stuff entering the atmosphere because you always see more flies hit your windscreen than your rear windscreen. Same kind of idea.
Yeah.
When we get a meteor shower, what's happening is we're passing through the area of space where the Earth passes near the orbit of either a comet or an asteroid, and typically it's a comet. Now, every time a comet goes around the sun, that dirty snowball or snowy dirt ball gets hot. the volatile material on the surface is too hot to stay solid, so becomes a gas in a process called sublimation. And you get jets erupting from the comet, shrouding in gas, which is then blown away from the sun to give you the tails. Those jets erupting into space carry with them dust. Now, biggest bits of dust are pushed away so gently they'll fall back to the comet and clog it up, and some comets eventually turn off because of this. Also is the reason most comets are only active from a few locations on the surface, not uniformly, because most of the surface is clogged up, and you've just got a few active areas where volatile material is exposed.
Yeah.
But that dust that's ejected from the comet is ejected with speeds measured in meters per second or centimeters per second, from an object that's traveling at a speed measured in tens of kilometers a second. So what that means is that that dust is moving away from the comet at a speed almost identical to the speed the comet's traveling itself. I guess it's like if you're driving along the road and you drop a tennis ball out of the window, until the wind resistance pushes it back. If there wasn't a wind resistance there, it would move along with the car, just drifting away very slightly based on the speed you pushed it out of the window. Same idea.
Yeah, I actually saw a really great experiment once where they were, how did they do it? They had a guy on the back of a truck and they were driving at like 100 kilometres an hour, and they shot him off the truck in the opposite direction at the same speed, and he just stopped where he landed.
Oh, it's brilliant. I think Mythbusters did something similar.
Yeah,
And
it's amazing.
our common sense is
It's
a
simple
weird
physics,
thing.
really.
Yeah. Simple physics is great, but our common sense breaks down in some situations because our common sense is a naturally inherited thing about the world at the speeds we experience it. And so we tend to think if you're running forwards at 10 kilometers an hour and you throw something forwards, it will travel a bit faster. That breaks down when you get to relativity. There's all these weird things around it. Where our common sense gets it wrong for comets and for the dust, and it took me a long while to get my head around this because it's a bit counterintuitive. If you eject dust from a comet, you can eject the dust forward or backwards. So you can imagine this jet from the comet working a bit like a geyser, turning off when it gets dark and it gets cold, and then turning off again in the morning when it gets hot again. That can throw dust forwards, sideways, and backwards, or any combination of the above. So that means this comet is throwing out dust at a speed of meters per second, a bit like a sprinkler into space. The dust has a forward component to its speed. So it could be going sideways but a little forward, or it could be going head on in front of the comet. That is now traveling around the sun faster than the comet is, which means it will move onto an orbit with a longer period than the comet. So the next time the comet comes round, that grain of dust will arrive after the comet. So dust thrown forward ends up behind.
Yep.
And similarly, dust thrown backwards is moving slower than the comet, which puts it on a slightly shorter period orbit, and therefore it will arrive ahead of the comet next time. And that little bit of sideways motion also means it will spread out a little bit in space. What this means over time periods is that comets, every time they come round, essentially shed what becomes like a javelin shape, a spear of dust into space with the comet at the centre, like a spike. And that spike gradually diffuses over time, spreads out further and further ahead and behind the comet. And so over a long time scale, you eventually end up with the comet's orbit shrouded in dust. And the dust can be quite spread out over millions of kilometres.
Yep.
These orbits are oriented randomly in space, so many of them don't intersect the Earth. Even if the comet gets closer to the sun than we are at its closest, passes above or below the Earth's orbit, nothing happens. But for a subset of them, the comet will, in its orbit, have the potential to get very close to the Earth, so its orbit and the Earth get very close together. And in those cases, every time we go around the sun, if that comet's been laying dust down for a while, we'll run into the dust every time we go around. And that dust will hit the Earth's atmosphere, which means we're going through a dirtier bit of the solar system, and we get more meteors. That's when we get a meteor shower. But the other telltale thing for the meteor shower is all the dust grains that hit the Earth in a meteor shower are moving essentially parallel to each other. They're all following the same orbit around the sun, hitting the Earth from the same direction at the same speed. So all this dust is coming towards you from a single point in space. So from your point of view looking at the sky, when you see those meteors part of a meteor shower, they appear to appear anywhere in the sky, but if you trace them back, they'll all point to a single point in the sky. That's something we call the radiant, and that's effectively the point in space they're traveling towards us from, and they diverge because of perspective. They're coming closer to you. So every meteor shower has a radiant in the sky. The April Lyrids have their radiant in Lyra, although for a fair part of their time it's actually in Hercules, it drifts a bit. The Perseids have their radiant in Perseus, the Geminids in Gemini, and so on. So that's all well and good. If the radiant is below the horizon, that means the meteors are hitting the other side of the Earth and you can't see them because the Earth's in the way. So first point with a meteor shower is, unlike some of the media reports, you can't see meteors for that meteor shower at any time of night. You can only see them when the radiant's above the horizon. Point number one. Point the second is, the higher in the sky that radiant is, the more head-on into the stream you're going, so the more meteors you'll see. Now, the analogy I'd use here is, if you imagine getting your hose pipe and having it on that shower mode, you know, where water's coming out from many holes all at once. If you hold that hose pipe vertically and turn the tap on, all the water from that hose pipe will hit a relatively small area of the ground. If you turn that hose pipe to 45 degrees, that water will spread out over a larger surface area.
Yep.
Now, if you imagine the meteors, the dust in a meteor shower coming in towards the Earth, the more directly overhead your point that they're coming from is, the more meteors you'll get in a certain volume of the atmosphere. And the lower to the horizon that point is, the more you'll spread those same number of grains of dust out. So the higher in the sky the radiant is, the more dust is hitting the part of the atmosphere you can see from your location, so the more meteors you get. And what this means is that the lower in the sky the radiant is, the fewer meteors you see. And so you see the most meteors for a given meteor shower when the radiant is near what we call culmination, where it's nearly highest in the sky. For the southern hemisphere, when it's nearly due north. For the northern hemisphere, when the radiant's nearly due south. So, all well and good. But what that means is that from different locations on the Earth, a given meteor shower will give you a different strength of display. The April Lyrids, their radiant is 34 degrees north of the equator. So that means if you lived 34 degrees north of the equator, at about 2 a.m. in the morning, the radiant will be overhead and you're in the best place on the planet to see the meteors. If you had perfect vision, perfectly dark sky, you'd see a number of meteors, 15 to 20 per hour for the April Lyrids, and that's called the zenithal hourly rate. That's the number of meteors you'd see in perfect conditions with perfect eyesight, with no light pollution, if the radiant was overhead. The lower the radiant is in the sky, the more that number shrinks. So the ZHR is the theoretical maximum number you'd see. So, good meteor shower, not a great one from the northern hemisphere, but for us in Brisbane, let's say 26 degrees south, the radiant of the April Lyrids at its highest in the sky is only 30 degrees above the horizon. That means that the volume of space where the dust is arriving is doubled. So you'd only see half the number of meteors. So instead of 20 per hour, you're down to 10 an hour immediately, before anything else kicks in. And the further south you go, the lower the rates are. But the problem is, the journalists covering this will pick up on a Northern Hemisphere article and just repeat it. There's this meteor shower happening. You can see them all night, every night. Well, that's not right. If the radiant's below the horizon, you can't see them. And you'll see 100 per hour. And that's because they've seen the zenithal hourly rate quoted as 100 per hour. And they just use it as a number.
Yeah.
Unless you are incredibly, incredibly fortunate, you will never see the same number of meteors as the ZHR predicts. Because the radiant won't be directly overhead, so the rate gets lower. Your eyes are not perfect unless you're one of the very rare observers. The rates will get lower. There might be light pollution. The fainter meteors are not seen. The rates get lower. The moon might be in the sky. The fainter meteors are not seen. The rates are lower. So you will never see a number of meteors in the sky equal to the ZHR unless the meteor shower is more active than predicted, in which case the ZHR will be higher and you'd see more. Where this really comes in is for meteor showers like the Perseids. The Perseids are one of the big three. There are 3 awesome meteor showers a year that are by far the best in a given year. They're the highest rates, the most dust coming in, or the highest speed. The Quadrantids in early January are very, very short-lived. They're a weird shower. You've got a very low rate of meteors for most of the time they're active, and then a very narrow spike that can be very big. But if you manage to see that spike, there's a lot of meteors. They're only really visible from the northern hemisphere. The Perseids in August are probably the most storied meteor shower, with long history of observations. linked to Comet Swift-Tuttle, which goes around every 120, 130 years. Incidentally, will be incredibly spectacular in the year 2126 if people hang around to see it.
Yeah, okay, I'll write that in my diary.
Perseids are brilliant, but their radiant is at about 55 degrees north in the sky. Fabulous from Northern Europe, fabulous from North America. Places north of the equator get a really good show. But we get articles every year on commercial media here in Australia saying, the Perseids are happening, go out tonight and you'll see 100 metres an hour. And for most of Australia, the radiant never even rises. Never, south of about 35 degrees south, the radiant will never rise. I think that's about the latitude of Sydney. North of that, it will rise, but it'll be very low to the horizon, so you'll see a much lower rate, unless you're in the top end. If you're in the top end of Australia, it's a bit different. And so, when you see articles like this, you need to engage your science brain and say the journalist's wrong.
Yeah.
Where's my location? What's the radiance declination, which is latitude in the sky, effectively? Figure out how high in the sky it'll get, and that'll give you a feel for what you might actually see. Now, if you want to look at the meteor shower calendar and figure out when there are good ones happening, the International Meteor Organization is my go-to on this. They're a fabulous organization that put together every year a calendar, and that calendar lists all the meteor showers from the incredibly minor ones that give 1 meteor every 2 hours, to the major ones. And every year it writes about the conditions in terms of moonlight as well. Because if the moon is bright, you will see far fewer meteors. And coming up in a couple of weeks from when we're having this discussion, but in the past as we actually go live to air, you've got the peak of the Eta Aquarids. Now, the Eta Aquarids are one of the few showers that's better for Southern Hemisphere than Northern Hemisphere. Fragments of Comet Halley, and they're at their peak around the 3rd to the 7th of May, have quite a broad peak. But this year, the moon is a waning gibbous. So at the time of night when you could see these meteors, the sky will be really bright, and so far fewer will be visible than normal. And you can get that from these calendars. But the highlight of every year for meteor showers is the Geminids in December, and they are pretty much global as a phenomenon, and they're brilliant everywhere. Obviously better for the Northern Hemisphere than the South. That's like a recurring theme. But they are great every year, and this year moon will be effectively new. So if you want to go see the Geminids peaking on the 14th or 15th of December, they're the highlight this year, and pretty much every year.
Okay. We're going to take another breath, and then we'll come back and wrap it all up in this episode of Space Nuts with Andrew Dunkley and Jonti Horner.
Listen, Tranquility Base here. The Eagle has landed.
Space Nuts.
One of my big frustrations when I want to observe comets is I live on a very flat area of the planet. We don't have mountains nearby. We barely have hills. And a lot of the comets are visible in the low horizon just after sunset or thereabouts. And they're short-lived, and they're below the horizon way too quick, which makes astrophotography a real pain in the butt for me. But it is just a quirk of where I live. I believe that we do have some pretty spectacular ones coming up. The one that I've seen in my life that was the most spectacular for me was in 2007, January 2007. It was Comet McNaught. It was amazing. Like naked eye comet wise, it was unmissable. It dominated the sky for quite some time. We don't see many like that though, do we?
We don't. Now, Comet McNaught was probably the brightest comet since the 1960s, and it was truly a great comet. Now, when we talk about the brightest comets and the ones people want to see, great comet is the appellation people attach to comets, and it's got a woolly-ish definition. It's basically the comet was bright enough and spectacular enough that even people who weren't that interested could just step outside and see it. Comet McNaught's definitely like that. Arguably, Comet Chichin Chan Atlas in 2024 and Comet Atlas in early 2025 just made that threshold. So if you saw those comets, you'd probably say they are right at the lower end of what we consider a great comet. On average, if you go back through historical comet records, you'd probably get about 10 great comets per century with very wide variance. And that's not one every 10 years. They're like buses, you wait 30 years and two come along at once. And you saw that back in 1996 with Comet Hale-Bopp and Comet Hyakutake, which were visible in the sky at the same time as great comets. It's really hard to predict when they're going to come in, but we've seen some really fascinating advances in the last few years on two fronts. Firstly, our ability to find things early has improved. We've got better telescopes, more automated surveys, and Comet Maps earlier this year, which turned out to be a bit of a disappointment for many people, is a really good example of that. That's a member of the Kreutz sun-grazing family, and the Kreutz sun-grazers have numbered many of the brightest great comets of the last couple of thousand years. Comet Maps was the earliest we've ever found a Kreutz sun-grazer on the way in, earlier even than Comet Ikea-Seki, which was probably the brightest comet in the 20th century back in the late 1960s. And so people's hopes were high, but in reality it was quite a small fragment of the Kreutz parent sun-grazer. These Kreutz comets are all fragments of a bigger comet in the past, and it just fell apart on its way in, nothing to see here. But our ability to find things earlier means that we get more warning when a bright comet's coming. Now, that's not absolutely guaranteed. We had a comet, and the name of it slipped my mind, Comet 12, 18 months ago. No, I think it was like last September, that was discovered when it was almost naked eye visibility. It just about became naked eye visible. Wasn't great by any means.
Swan.
But we got no warning. That's it, Comet Swan. And the reason that was found so late was it came at us from behind the sun and suddenly popped into view. So that does still happen. But with facilities like Vera Rubin coming online, we're going to find comets earlier and earlier, which means we get more prior warning. But it also means that the uncertainty about how bright they're going to get is possibly even higher, because we're almost finding them now before they've really started to become active, while they're far enough from the sun that we're almost seeing a bare nucleus, or we're seeing a much smaller comet that's had a little bit of an outburst at that distance. And when they're that far away, we effectively can't tell the difference. They're still like a single pixel. There's a really good example of this in the form of Comet Chichin Chan. Not Comet Chichin Chan Atlas from a couple of years ago, but Comet Chichin Chan that has just been discovered in the last couple of months. Comet C/2026 C1. As we record this, that comet is still more distant from the sun than the orbit of Saturn.
No.
It was found a couple of months ago. It will not be at its closest to sun perihelion until November 2028. So we've got 2.5 years to wait. Now, what factors into a comet's brightness is very complicated, but it can boil down to a few different things. Firstly, if everything else is equal, so imagine we only change one thing, typically the bigger the nucleus of the comet, the bigger its surface area is, so the more dust and gas it can produce. And we see the comet from the light that is reflected from the dust and gas. That's what makes the tails and the coma. The snowballs at the head are actually pretty small. Comet McNaught was only about 5 kilometers across for the nucleus, but it grew tails more than 300 million kilometers long.
Yeah, that's
a little bit different.
Incredible.
So if you have two cometary nuclei that are in all senses identical other than their size, the bigger one will typically be more active and produce more gas and dust. However, some comets have a larger fraction of their surface active than others. Some comets are almost dormant because they're clogged up and there's very little activity even from a larger nucleus. So already a bit complex. But first rule of thumb, the bigger the nucleus, the more likelihood there is that it will be able to produce a lot of gas and dust and be more spectacular. With Comet Chichin Chan, that's interesting. We found it so far away, which suggests it is either a comet with quite a large nucleus, because it's probably not that active at that distance, but it may have just had a bit of an outburst of activity driven by something like carbon monoxide, which can turn from solid to gas at a very low temperature. So it might be masquerading as a bigger comet than it is, and we don't know.
Okay.
The next thing that factors into how bright a comet gets is how close it gets to the sun. So the closer it gets to the sun, the hotter its surface gets, and the more strongly it will be active. So with Comet McNaught, you had a 5-kilometer nucleus, which is fairly respectable, but not as big as Hale-Bopp, which was 50 kilometers. Hale-Bopp was ridiculous. But Comet McNaught got very close into the sun, so it got really incredibly intensely active, was throwing off huge amounts of gas and dust. So that contributed again to more stuff to reflect sunlight. And also being nearer to the sun, the intensity of light reflecting off it's higher as well. So kind of get a double whammy there. The other factor is how close they get to the Earth. So if you have two comets that are the same size and the same distance from the sun, and one is closer to the Earth than the other, the one closer to the Earth will be brighter, but will also potentially be more spread out and more diffuse in the sky. So that brightness might be spread over a different area. You've then got subtleties of how dusty or gassy they are. Some comets, like Comet Pan-STARRS, seem to be more gassy. Some comets, like Chichin Chan Atlas, was more dusty, and that can have an impact on how they brighten. Bringing all this back together, though, for Comet Chichin Chan, at its closest to the sun, it will be a little bit further from the sun than the Earth is. So it's not like Comet McNaught that's going to get really close in. But 1 AU from the sun's fairly respectable. It can still maintain a fairly decent level of activity at that distance. Comet Hale-Bopp didn't get much closer than that and was fantastic. So that's in its favour. It's going to get close enough in that you could get a decent level of activity. Also, because it's only going to get that close to the sun, it'll take a bit longer to pass through the inner solar system. Comets that get really close to the sun get travelling incredibly quickly at that point, so they tend to whip in and whip out fairly quickly, whereas with Comet Chichin Chan, it's going to hang around for a fair while. It is potentially quite a large cometary nucleus, but we don't know yet. This is the caution I give. If it turns out that we've caught it during an outburst, it may be a bit of a disappointment. If we've actually seen it as a bare nucleus, that augurs very, very, very well. What this all suggests is that Comet Chichin Chan has the potential to be bright in late 2028. Depending on which fit to its current brightness you use, it could become barely naked eye visible, which is still pretty good. You know, we see 20 or 30 comets a year, and only maybe one will get to naked eye visibility. Or it could get as bright as the brightest stars, and if it gets as bright as the brightest stars, then it gets into great comet type territory. That's a factor of 100 difference in brightness between those two extremes. And it could get brighter than the brightest extreme there or fainter than the faintest extreme. We just don't know yet, but having found it so early augurs well. But typically, predicting the next great comet is a fool's bargain until it's discovered. What we can say is that there are a few periodic comets that will be great in the future. Comet Halley will be a lot better in 2061 than it was in 1986. In 1986, we had the worst apparition of Comet Halley for 2,000 years.
Tell me about it.
Yeah, a bit disappointing. 2061 will be better.
Oh, good. Well, I don't know if I'll be around by then, but probably not. I'll be 99.
Make everybody feel really cheerful. It's now closer to Comet Halley's next apparition than the last one. It turned around, I think, last year, so it's on its way back.
Yeah.
Comet Halley will be even better in 2135. Will be really good that year, and that will be the best apparition for a couple of 100 years. Comet Swift-Tuttle will be incredible in 2126. We know that because we know pretty much exactly when it'll come back. We know where it will be compared to the Earth and the Sun. There is a suggestion that in 2097 we may have the comet of the century or close to it. This is research that came out last year. One of the greatest comets of the last 1,000 years was Comet de Chezeaux in 1744, also called Comet Klinkenberg, comet that is famous for having had 6 tails, incredibly bright, almost visible in broad daylight. A couple of astronomers, I think the lead researcher on this was Mike Meyer, published a paper last year that went back through historical observations and found a number of previous comets over the last 2,000 years that were all incredibly bright, really spectacular, but seemed to have been moving the same as that comet, linked them together. And it's a very compelling tale that if their research is correct, that comet actually has an orbital period of just a little bit less, just around 450 years, I think, 400 years. No, 350 years, wouldn't it? Do the mental arithmetic. Yeah, about 350 years, which means it should return in 2097. And if it does, it will be awesome. Sadly, I don't think you or I will be around for that.
Probably not.
Probably not, but things like that we can predict. But most
Fred will be, but
no.
Absolutely.
Fred is indestructible, and I'll stand by that. But most of the big cometary nuclei coming through are on such long period orbits, with the exception of Halley and Swift-Tuttle, that their apparitions are so infrequent that we've not identified them as periodic visitors, and many of them have periods of thousands or tens of thousands of years. So we typically only find them on their way in a few weeks or a few months before apparition. In case of Comet Hale-Bopp, it was 2 years, which was exceptional at the time. In case of Comet Chichin Chan, it's more than 2.5 years away. But our technology has improved hugely, so I don't think it's fair necessarily to say that Chichin Chan will be another Hale-Bopp. But if you look at the brighter end of the predictions, it could be naked eye visible for 3, 4, 5 months.
Wow.
Which would be awesome. And it would potentially be circumpolar for us in the southern hemisphere, because at its closest to the sun and the earth, it's going to be way south. not going to be good for the northern hemisphere. But we can't really predict that. It's the same with meteor showers. We can predict the annual ones, roughly how good they're going to be.
Yep.
And if you go back to when I was a kid, we couldn't really predict meteor storms, meteor outbursts. And that's one of the things people really love to see. So Geminids are great. Northern hemisphere, you'll see maybe even 80 or 100 an hour at their peak in the early hours of the morning. I've seen 50 an hour from our latitude near Brisbane. They're really good. But what people really want to see are meteor storms, and they're much rarer. There's a few amazing ones historically. There was one in 1833 that was linked to the Leonid meteor shower that had a rate in excess of 100,000 an hour, was best seen from the contiguous US, and it was bright enough there were sufficient meteors in the sky that miners in the US were woken from their campsites by the light shining through their tents, and people were convinced that the end times had come, the apocalypse was here, because he were getting as many as 20 meteors per second.
Incredible.
Now that, in the way that kind of Tycho's observations in 1577 were probably the birth of modern cometary astronomy, 1833, I think, was possibly the birth of modern meteor astronomy, because there'd been a storm from the Leonids in 1799. People predicted that there might be another one in 1866, because maybe this was happening every 33 years when the comet came back, and indeed that happened in 1866. And so that was a bit like the birth of modern meteor science. And after that, people said, well, there'll be one in 1899, and there wasn't. So that then tripped people up. So thanks to that, we've gradually developed a better understanding of the physics of how meteor showers work. And I'm aware time is running away from us, but for people interested in this, in the run-up to the heavy Leonid activity in 1999 through to 2002, there was some amazing research done by David Asher from Armagh Observatory, and I think fondly on David because he was a lovely mentor to me when I visited Armagh in 1999. Very quiet guy, but incredibly talented scientist. And he did this remarkable work making predictions of when we would and wouldn't get Leonid storms by modelling the ejection of dust from the cometary nucleus and evolving the dust forward in time. And go back way earlier on, I mentioned these javelin-shaped spikes. He effectively modelled those and figured out where the spikes will be. And a slight nudge up or down means that the Earth will run through the spike or not. And the great Leonid storms are produced by dust left behind just 1 or 2 revolutions ago. So the activity between 1999 and 2002 resulted from a few different streams. The older they are, the more diffuse they get. But now we have the ability for comets we know well and meteor showers we know well to figure out where those spikes are roughly going to be, how long they are, and make predictions going forward. Now, there aren't any great meteor storms predicted in the relatively near future. The Leonids are not likely to give major storms in 2033 or 2066, but will give increased activity. The reason for that is Jupiter and Saturn are pulling those javelins around and making them miss the Earth. The Leonids will probably return in force in, I think, 2097, with the possibility of a storm of like 20,000 an hour. But we're getting to understand that. So with meteor showers, we can predict the annual showers. They're very reliable. They gradually get better and worse with time as the streams move around and we intersect more of the material or less, but they're pretty reliable. Outbursts are harder to predict, but we're getting better at doing it. But predicting an outburst from a shower we've never seen before, or a shower that's incredibly rare, we typically can't do until it happens, because we need to have a feel for what it's done in the past. So we occasionally will get an outburst of a meteor shower we've never seen before, and you can't predict that. And that's when it's really exciting, because then you can start to learn about a new meteor shower being born. You can learn about the comet that birthed it, put all that together. And that's one of the things where I'll go out, and I love my meteor showers. I'll sit out under the sky and watch them. But I would love to just be outside when there's an unexpected outburst, when we see something new, like a meteor shower being born for the first time.
And that's what we recommend to all our Space Nuts listeners. Get up at 2:00 every morning, every day, and go out and just wait. And, one day you'll get lucky. Might take 20 years, but...
It doesn't have to be 2 a.m. I mean, there is a little bit of a preference for meteor showers to be more active in the morning hours and the evening hours, but that's purely a geometry thing. Yeah. It's linked a little bit to the direction of the Earth's motion and the direction things are crossing the Earth's orbit, in that if you think about something crossing the Earth's orbit at right angles to the Earth, Because the Earth's moving forward at 30 kilometers a second, the direction you would see that coming from is actually a bit ahead of you because you've got the addition of the speed the debris is going and the speed the Earth's moving. So meteor showers that are visible with radiance that will be in the morning sky, you've got a little bit of an additive effect between the speed the debris is going and the speed the Earth's moving, which means the average impact speed of the debris is higher and you get more meteors. But also you get this effect of the Earth's motion being a bit like you're driving into a snowstorm. You know, if you're driving into a snowstorm where there's no wind and the snowflakes are falling down vertically, you will perceive them as coming from in front of your car, not overhead. And so there's a preference for meteor showers to be slightly more likely to have activity that peaks in the morning hours than the evening, but that's not a guarantee. There are some meteor showers that are at the highest where the radiant culminates in the evening sky. It just depends. Some, like the Aquarids, are only visible for a couple of hours before dawn. There's even a few meteor showers that are daylight showers where the radiant's only really above the horizon during the hours of daylight. And we know about them primarily from radio observations, radar. Not radar, people listening to radio, reflecting off the ionized streaks that the meteors leave in the ionosphere. That allows you to see over the horizon to radio stations that are broadcasting that you don't normally get, so you can hear meteor showers.
Yeah.
So we know there are daytime showers that we cannot see at night, and some of them are possibly as active as the Geminids or the Perseids. If we could turn the sun off, I mean, that would be a bad thing. Please don't do it. If you're a supervillain listening, do not take this as an idea. But if we could turn the sun off and see, there are a couple of meteor showers in the daytime that could be pretty spectacular.
It is all very fascinating. And I suppose the best advice would be to go and look for the better sources of forecasting rather than trying to figure it out for yourself. And you've mentioned a couple of them already, Comet Maps and what was the other one about meteors?
For meteors, I really strongly recommend the International Meteor Organization. If you go to their website, hover over the resources link, click on it to get the drop down, click on Meteor Shower Calendar. They have on the right-hand side the best showers of the year with information on what the moon will be like. But there's also on the left side a PDF that you can download that goes into much more minute detail and talks about even the more minor showers. And that's a very good point of truth for meteor showers. I kind of describe them being like three tiers of meteor showers, ignoring the outbursts. There are the big three, which are the Quadrantids, the Perseids, and the Geminids, which are, even if you're not that interested at all in space, and if you are, thanks for listening to the podcast anyway, but it's not really our target audience. But even people who are not that interested, that's a spectacle you can go out and see with them and share with them. Just make sure that you figure out when the radiant rises from your location, because you don't want to turn people off by looking at a time when you can't see meteors. So for the Geminids, the best time is around 2 a.m. But depending on where you are in the world, from our latitude, you're looking at, you can't see any before 9:30, 10 o'clock at night. Obviously, if you're somewhere with daylight savings in the Southern Hemisphere, add an hour to that. So for you down in New South Wales where the clocks change, you're talking after 11 p.m. for you. But if you're in Northern Europe, the Geminid radiant never sets. So where I grew up in the UK, as soon as it got dark, I could see them. The rates still got better through the night. Similarly for the Perseids in particular, Perseids are a Northern Hemisphere only thing. It's light until quite late, certainly for the high northern latitudes like the UK, but as soon as it gets dark, you can see them. So they're the showers that are well worth going out to look at as a beginner. And you just sit out there. I would figure out where the radiant is and look 30 or 40 degrees to the left or right of it to get the best balance between a lot of meteors, but decent ones to see. And just get a comfy chair, lie back, wrap up warm with the people you love and tell stories and relax. And occasionally you'll see something good, and it's quite addictive. You think, I'll go to bed, but I just want to see one more. And then, well, that was rubbish, so I want to see another one that's actually good. You've then got like the mid-tier showers, which can be decent, but you need to be a bit more dedicated for. These are the ones where you might see 10 or 15 an hour instead of 50 an hour. And I wouldn't recommend people who are beginners go out and see them because there's not enough happening. And that's why I worry about coverage for the April Lyrids, even in the Northern Hemisphere, because they're just not that good. If you're someone who's really keen, you'll enjoy them. But for most people, they'll be a letdown, and you don't want to turn people off the subject. Then there are the minor showers that you frankly need to be very obsessive to follow. And I've seen stories of a lot of the science of this has been done by amateur astronomers and quite often by people who are quite obsessive about the topic. And I saw one guy who was in North America where it gets brutal cold in the winter, who built himself an insulated coffin with an incredibly transparent glass lid that he would carry out with him that was big enough for him to have a notebook and write down the details of every meteor he saw. So he could lie out in minus 40 degrees, and I think that's units ambivalent. I think Fahrenheit and centigrade are very similar at that point. But he's in an insulated box that keeps him warm, and he'd lie out all night recording 2 meters, 3 meters an hour. That isn't for me, but it is for some people. But when you see a meteor shower with a ZHR of less than about 20, I'd probably leave that unless you're really keen. If it's got a ZHR of 50 plus, well worth looking out for. But look for when the time of maximum is. For most meteor showers, they've got what we call a full width half maximum of about 24 hours. What that means is that the rate only stays above half of the peak rate for about 24 hours. For 48 hours, then it'd stay above a quarter of the rate, and so on. For the quadrantids, it's full width at quarter maximum of about 12 hours. So that means if you're 6 hours away from the peak, the rate is already down to a quarter of that peak. It's a very sharp peak. And if you're looking at the wrong time, the show won't be as good as you'd like it to be, and you'll be disappointed.
So much to consider, Jonti, but fascinating. Comets and meteors, there's so much to talk about, and we probably didn't really cover absolutely everything, although we did hit on quite a fair bit of info. And, of course, we do welcome questions and comments, so please go to our website and click that little AMA button at the top, and you can send us questions and comments in text and audio form. Don't forget to tell us who you are and where you're from, but we're going to wrap it up there. Jonti, thank you so much. We'll catch you on the next show.
Thank you very much.
Professor Jonti Horner, Professor of Astrophysics at the University of Southern Queensland, our special guest commentator while Fred's on the other side of the planet looking at meteors. And just a special word for Hugh in the studio. He's been a little unwell lately. Hugh, get well soon, mate. We're all thinking of you. And from me, Andrew Dunkley, thanks for your company. We'll catch you on the next episode of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.